All right, guys, welcome back. So, yesterday we went over the idea of how to solve a system of equations using elimination through addition or subtraction. Okay, so if we go back for a second, we think about those two ideas. If we are going to solve by addition, it's because we see two um, variables, either x or y. So, for example, maybe if we had 3x plus 5y equal 12, and then we also had 3x minus 4y equaled 8. In this situation, we would want to use the idea of subtraction, because subtraction in this case would cancel those two like or identical variables out. 3 minus 3 would give us a total of 0. Now, on the other hand, if we had something like this, for example, if we had 5x plus 2y equaled 8, and we had 3x minus 2y equaled 4, okay, here subtraction would not cancel those out because they're already opposite of each other. In this situation, in order to make those two cancel out, here we would want to add. All right, we would add those two together, and in this case we would find out that 8x is equal to 12, and we would divide both sides by 8, and we would get an answer of 4 over 3, or 1.3 repeated, for an x value. But it's all based off the fact that here those variables are those coefficients, I guess we should say. The coefficients are opposites of each other, and so we add. Okay, so everything that we do today is going to lead us back to wanting to see something like that take place, where we either have coefficients that are the same or we have coefficients that are opposite of each other. All right, so here, if we take a look at this problem, we notice that currently, the way it sits, using the idea of addition or subtraction wouldn't benefit me. Okay, if we just run through this for a second, if I tried to add these two things together, 1 and a negative 3, that would leave me with negative 2x. 2 plus 1 more, that would leave me with 3y. And 11 plus a negative 5 would leave me with 6. I still have two variables. I still have x's and y's. I didn't get anywhere. I didn't eliminate anything. So adding, not the right idea. Okay, if we come back here and we try to subtract these two from each other, 1 minus a negative 3, remember minusing a negative, that would turn into a positive, so we get 4. 2 minus 1, that would leave me with 1. And 11 minus a negative 5, so minusing a negative again would be addition, I get left with 16. So again, I don't have anything that eliminated, so it didn't help me. So that's why the heading here does not say addition or subtraction, but in case this one says we're going to multiply first, because what we need to do here is we need to make that elimination get ready to happen. Okay, and so here's what we're going to do. We're going to make a choice. We're either going to focus our attention on the x's or we're going to focus our attention on the y's. Okay, so in this case, the way I currently see it, I think it would probably be easiest if I took this bottom equation right here, and if I do the same thing across the entire problem, okay, nothing has changed, and I'm going to multiply that entire equation by 2. All right, now then hopefully you'll see why here in a second. So if I take the top equation, I get x plus 2y equals 11. Okay, nothing changed there. But in the bottom one, if I multiply everything by 2, I get negative 6x, I get a positive 2y, and I get a negative 10. And at this point, hopefully you're recognizing right now that those y values, those coefficients are exactly the same. So how do we make two things that are the same go away? We subtract. Okay, that leaves me with 1 minus negative 6. Minusing a negative is really addition, so I get 7x. Okay, 2 minus 2, those cancel out. And in the end, I get 11 minus a negative 10. So minusing a negative again is addition. So that turns into 21. We divide both sides by 7. We find out that x is equal to 3. All right. And if I take an x value of 3, I'm going to go back to one of these two original equations. I'm going to use the top one. So that will be 3 plus 2y is equal to 11. I'll minus the 3 from both sides. 2y is equal to 8. And so ultimately y is 4. Done. All right. So there, I went ahead and I multiplied in order to make that elimination take place. Okay, so I did what I wanted to happen. All right. So let's try one here because the example I have at the bottom is a little bit different. So I'm going to set this one up right now. So negative 4x plus 9y is equal to 9. And on the bottom, I have x minus 3y equals negative 6. Okay, so if you take a look at that right now, I don't see anything that's currently ready to eliminate. Okay, I don't have two coefficients that are exactly the same. I don't have two coefficients that are opposite of each other. Okay, so what I'm going to do here is if you look at this, I think we have two choices. We could make this turn into a 4. Okay, we'd have a negative 4 and a positive 4. We could make those go away. All right, I think that's one option. I think the other option would be if this negative 3 right here was a 9, then we would have a 9 on the top and a 9 on the bottom. Again, we could make those go away. So at this point, it's about us making a choice. Would we rather see the bottom x have a 4 in front of it? If that's the case, we're going to multiply everything in the bottom by 4. Or would we rather see the bottom have a 9? And in order to make that a 9, we'll multiply everything in the bottom by 3 because there's already a 3 there, and the 3 and the 3 would give us a 9. So I think just for the sake of this problem, we'll probably just multiply everything by 4. Okay, so momentarily, I'm not going to do anything with this value here. Okay, so that top equation stayed exactly the same. The bottom equation is now going to become 4x minus 12y is equal to a negative 24. Because I have opposite values of x, we add opposites to make them cancel each other out. So looking at my y values, a positive 9 added to a negative 12 is negative 3. And a positive 9 added to a negative 24 leaves me with a negative 15. So at this point, if I divide both sides by negative 3, I get y is equal to 5. So over here, I know half my answer is 5. All right, and then I'm going to take that answer of 5 back to one of these original equations. I would say probably if we take that equation right there, it looks like it's probably the easiest to work with. So that would be x minus 3 times 5 equals negative 6. So x minus 15 equals negative 6. I will add 15 to both sides, and I get x is equal to 9. Okay, so a little bit different than yesterday because we didn't originally have two things that were ready to cancel each other out. However, by using the idea of multiplication, then I can make that take place. I can make the elimination happen. Okay, in these two examples, so in this one here and in this first one that we looked at, notice we only multiplied one of our equations because we were able to make one equation look like the other equation. Here, by multiplying by 2, I essentially got my 2's to be the same. Because they were the same, I went ahead and subtracted and I canceled that out. Okay, the only other option that could take place might be something like this, where you look at, move this out of the way for a sec, you look at your x's and y's and none of them are ready to cancel. Okay, we have a negative 5 and a positive 2, and then we have a 2 and a 3. So nothing's ready to cancel. And secondly, there's no way for me to make one of these variables look like the other. Okay, so what I mean there is I can't multiply this 2 down here by something. I can't like do, 2 times 2. That's not going to make it look like 5. I guess I could do 2 times 2.5. right? I mean, I could multiply this by 2.5. That there would give me 5, but now you're doing 2.5 times 3, and you're doing 2.5 times 10, and I don't know if that's really a good idea. And then conversely, the other option is the 2 and the 3 that are attached to the y. I don't know if you want to multiply something there that's going to make that happen. So instead of multiplying one equation, we're actually going to multiply both equations. Okay, so we're going to multiply both of these equations by something to make that cancellation or that elimination take place. So looking at them right now, if you look at the x's, you have a 5 and a 2. Hopefully you're thinking to yourself, I can make both of those look like the number 10. Or if I look at the y values, I have a 2 and a 3. Again, I can make both of those look like 6. So my suggestion to you would probably be to go ahead and multiply by the numbers that are going to keep everything the smallest. Okay, so in this particular case, that would probably mean dealing with the y's. So if that were the case, I'd multiply everything in the top by 3, and I'd multiply everything in the bottom by 2. Okay, so 2 brand new equations, this time instead of 1 new equation. So if I multiply everything in the top by 3, I get negative 15x plus 6y is equal to 96. 3 times 32, I think it's 96. And then on the bottom, you're going to get 4x plus 6y is equal to 20. Okay, so as you look at this right now, you have a positive 6y in both of these. What makes two things that are the same cancel out? That would be subtraction. Okay, so those are going to cancel. So you get negative 15 minus 4. It's negative 19x. And then 96 minus 20, 76. So if I divide both sides by negative 19, I'm going to get x is equal to, got to use my calculator, sorry, 76 divided by negative 19 is negative 4. So x has a value of negative 4. All right. And at this point, I'm going to take that answer of negative 4, and I think I'm going to plug it back into this equation here. Looks like it's the smallest. So 2 times negative 4 plus 3y is equal to 10. So negative 8 plus 3y equals 10. Add the 8 to both sides. 3y is equal to 18. So y is equal to 6. And I've got my ordered pair. All right, so there I didn't have anything that was ready to eliminate. However, by multiplying both the top and the bottom equation, I was able to find something that was common to both of them. All right, and I was able to get an elimination to take place. Okay, so we're going to try one more. All right, so let's use this. We'll go with 8x plus 14y is equal to 4, and negative 6x minus 7y. Sorry, I don't like it. Let's try this one instead. Sorry, too easy. And negative 10x plus 7y equals negative 25. Okay. If you caught that last one, I was going to be able to make my y's cancel out by only multiplying one of them. So here, we don't have the ability for that to happen. We're going to have to multiply something in both of these. All right, so as you look at both of these equations and you start to think about what am I going to multiply by, ask yourself, if I focus my attention on the x's, what could I make negative 4 and negative 10 look like? Now, the first option is obviously you just flip those coefficients, multiply the top one by 10, bottom one by 4. You can make them both look like 40 if you wanted to. Or you'd be a little crafty and maybe you could make them both look like 20 if you multiplied the top one by 5 and the bottom one by 2. If we look at the y values, we have a 2 and a 7. Okay, what's the first multiple of each of those that are the same? And I think it's going to be flipping those coefficients. So multiplying the top one by 7, that'd give you a 14. Multiply the bottom one by 2, that would give you a 14. So we just got to make a choice. We want to make x go away. We want to make y go away. Okay, I think for the sake of this one, I'm going to multiply the top equation by 7 and the bottom equation by 2. that is going to make these y values right here disappear, all right, or eliminate, which is what we want. Okay, so if I multiply everything by 7, I'm going to get negative 28x minus 14y is equal to, bust out my calculator, what's 14 times 7? I get 98. On the bottom, 2 times negative 10 is negative 20x. 2 times 7 is positive 14y. And 2 times negative 25 is a negative 50. Okay, so at this point, those y's are opposites of each other, negative 14 and positive 14. So we will add opposites to make that cancel. So negative 28 and negative 20, that's negative 48x. Those cancel. And then 98 minus 50 is also 48. So if I divide both sides by negative 48, I get x is equal to negative 1. So there's half my answer. X is a negative 1. Now I'm taking that answer back to one of my original equations. I think I'm going to choose that one right there. Okay, so it's going to be negative 4 times negative 1 minus 2y equals 14. So that's 4 minus 2y equals 14. Minus the 4, I get negative 2y is equal to 10. So y is negative 5. And I've got my second answer. Okay, so here again, nothing was ready to eliminate. However, a little multiplication first made that take place. Now I'm ready to do it. All right, so one more problem and we'll be done for today. Okay, if we take a look at this, this is kind of something I saw you guys struggling on the other day where we had to be able to write our own equations first. Okay, so if we take a look at this, it says Paige has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. Okay, so this is very similar to your homework from section 6.2 where we saw the people going to the movies. We knew how much it cost for them to go to the movies. We knew how many people went to the movies. We have to be able to write two equations here. All right, and our first equation is going to be all about the money. How much did things cost? Okay, so it says that the felt was 50 cents a sheet and the cardstock was 75 cents a sheet, and she spent a total of $7.75. In equation number 2, it's not about cost, it's about quantity. How many did she buy? So here, it's simply x plus y equals 12. Okay. Now, at this point, we have two equations. All right, some of you guys may be thinking, hey, substitution, right? Take that bottom equation, solve it for x or y, and plug it into the other equation. Not a bad idea. However, elimination might not be a bad choice either. Remember, in order to eliminate, you just have to make either your coefficients of x or y be the same or the opposite, and then add or subtract to make them go away. So as I look at this right now, I'm thinking to myself, if I just multiplied everything in this bottom equation by 0.5 or 50 cents, I'd end up with two equations that had identical x values. Okay, so here we see that 50 cents x plus 75 cents y is equal to 775. And in the bottom, if we multiplied everything by 50 cents, we would also have 50 cents x, 50 cents y, and now we have $6 instead of, or excuse me, 6 sheets instead of 12. Because the x's are the same, we want to use subtraction to cancel them out. In your y values, 75 cents minus 50 cents would leave you with 25 cents. So 0.25y is equal to, if we subtracted 775 minus 6, you would get 1.75. Okay, and then at this point, it's just going to be the division of 1.75 divided by 0.25. and that would say that y is equal to 7. Okay, so if you know one answer but you need to know the other, you got to take it back and plug it in. Hopefully you're picking that one as your choice, because if y is 7, that must mean x is 5. All right, so 5 sheets of the felt and 7 sheets of the cardstock would be your total of 12 sheets. But if you also took those numbers and multiplied them by 50 cents and 75 cents, you would get a grand total of $7.75. Okay, we can do this idea of a system. We can do it through graphing, we can do it through substitution, or lastly, we can do it using elimination. All right, remember, in order to eliminate, you must make your coefficients be the same or make them the opposite before you add or subtract. All right, message me if you guys have questions. Have a great day. Bye.